Hi, in today's video we're going to work on more ratios. We're going to go from ratio tables to equations using the value of a ratio. So we've been working on ratio tables. Equations are number sentences with an equal sign, and value is a fraction in simplest form. Okay, so let's get hopefully the top of your highlighter is popped and you are ready to highlight and do some practice. Okay? Jorge is mixing a special shade of orange paint. He mixed 1 gallon of red paint with 3 gallons of yellow paint. Based on the information on red and yellow paint, complete the table below. Okay, so I know for every 1 gallon of red paint, there's 3 yellow. So there's 3 yellow here, so I know there's a 1 here. The relationship is 1 times 3 gives you 3, which they wrote here, and the total paint in all would be 1 plus 3, which is 4. Okay, let's do the next one together. Again, as said, every ratio table has a multiplicative relationship. You multiply this by 3, we're going to multiply this by 3, this by 3, so on and so forth. So let's do this next one. 2 times 3 is going to give you 6. The relationship is 2 times 3 equals 6. 2 plus 6 gives us a total of 8. Ooh, I see a pattern here. We're skip counting by 4s. Okay, great. Ooh, there's a blank here. So what number times 3 gives you 9? Okay, well, if you work backwards and do 9 divided by 3, that's going to give us 3. 3 times 3 gives us 9. 3 plus 9 gives us 12. Okay, I'm going to guess that these next ones are going to be 16 and 20 because I know ratio tables have an additive structure. Okay, they can skip count by the same thing. So let's go back here. I have a blank again, so I have to figure out what number times 3 equals 12. Well, another cool thing is I can look, I'm counting by ones here. 1, 2, 3, 4 should fit. So 4 times 3 indeed gives me 12. The relationship is 4 times 3 equals 12. And 4 plus 12 does give me 16 total for paint. Wow, this is pretty fun. Okay, 5, 1, 2, 3, 4, 5, 3, 6, 9, 12, 15. Let me see if the pattern works. 5 times 3 does give me 15, and that's the relationship. Okay. Now, based on these structures and relationships, we can start writing equations. Okay, we're going to be using the variables r and y. We're going to write 2 equations to show the relationship between red and yellow paint. Oh my god, I love it. So we took the red paint, we times it by 3 to get our y. Too much y talk, it confused me, sorry. You take r times 3 and you get your yellow paint. But guess what? There were some blanks in here, okay? And think about this one and this one specifically. We took the yellow paint and we worked backwards. We divided by 3 to get the red paint. So those are the first 2 equations that we made, okay? The next 2 equations ask you to look at the red paint to the total paint, these 2 columns, and I'm going to highlight them. Just so you can see, you don't have to highlight them, just let me highlight them. This is a different relationship. 1 times what gives me 4? Well, it's 1 times 4. Let me see if that holds true for everyone. 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. Beautiful. So, down here, it's going to ask us to write 2 equations for the red paint and the total. Oh, just write 1 equation. I'm going to trick them. I'm going to write 2. Draw a second line for me. We took the red paint. We times it by 4 to get the total. You can also take the T total and work backwards, divide it by 4 to get the R red paint. Okay, really fun. Let's look at our next problem together. Jorge now plans to mix red paint and blue paint to create purple paint. The color of purple he has decided to make combines red paint and blue paint. Ooh, I have to make sure I have the order of my ratio. Red to blue, in a 4-to-1 ratio. If Jorge can only purchase paint in 1-gallon containers, construct a ratio table for all possible combinations for red and blue paint that will give Jorge no more than 25 gallons of paint. Okay, look how they try to trick you here. They gave you the red paint first, the blue paint second. This is red to blue. Okay, and now you have to switch it, okay, because they put blue first. So blue would be 1, red would be 4, okay, and the total, the relationship is 1 times 4 is going to give you 4, and the total paint is going to be 5, because 1 plus 4 is 5. Now, if you want to take a minute, you may pause this video and try to fill in the table with your partner. You can put your answers in the EduCanon questions that pop up, okay, and good luck. Hit unpause when you're done. Okay, the next one, if you skip count here on the blue paint, we're skip counting by ones with the additive structure. This one, we're going to skip count by 4s for the additive structure. Okay, and we're going to double check. 2 times 4 does give you 8. 3 times 4 does give you 12. 4 times 4 does give you 16. And 5 times 4 does give you 20. So let's check here. 1 plus 4, 5. 2 plus 10, 2 plus 8 is 10. 3 plus 12 is 15. And look, you're skip counting by 5s on this side. Ratio tables are such a beautiful thing. Now they want us to write 2 equations that can be used to show the relationship between blue and red paint. Take a minute with your partner. Stop and think. See if you can do this with on your own. Pause me if you want to. Okay? But I know for the blue paint, you are timesing everything by 4 to get the red paint. So it's B times 4 equals R. Now think backwards. What do I do to this 20 to go down to 5? You're scaling it down, okay? You are doing division. So you can work backwards and do R divided by 4 equals B. Okay, beautiful. And I'm sure the next one is going to ask me to write an equation comparing the red to the total. 1 times 5 gives you 5. 2 times 5 gives you 10. 3 times 5, 15, so on and so forth. So let's scroll down here. Let's write 2 equations. Ooh, it was the blue paint. I hope I didn't say red, but I think I did. Don't be too mad at me. Blue times 5 is going to give you the total. And if you worked backwards, you could take the total. You could divide it by 5. And that's going to give you the R red. Ah! There it is, the red paint again. The B blue paint. Okay, great. Let's go down to the next one. Okay. During a particular U.S. Air Force training exercise, the ratio of the number of men first, to the number of women was 6 to 1. Okay? Use the ratio table provided below to create at least 2 equations that model the relationship between the number of men and the number of women participating in this training exercise. So, they did it again. They put men first here, women second, and then they switched it on the table. Oh, those sneaky test question writers, okay? So now I'm going to skip count by 1s here. I'm going to skip count by 6s here. And here's my equation, and I want you to write this on your table. It's going to help you so much. 1 times 6 is going to give you this. 1 times 6 is 6, 2 times 6 is 12, 3 times 6, 18, 4 times 6, 24, 5 times 6, 30. So you take the women, you times it by 6, and you get the M men. Okay? Think about what you're doing when you're working backwards. You're taking the men, you're dividing it by 6, and getting the W women. Perfect. Those are our 2 equations. Now here's a question for us. If 200 women participated in the training exercise, use one of your equations to calculate the number of M. So we need the one where it's going to equal M, okay, and that is this one right here. So you are going to take W times 6 equals your M. You know your women are 200. You're going to substitute it in. You're going to times it by 6, and 200 times 6 is going to give us 1,200 men. Oh, what a great question. I'm going to let you and your partner complete the following 2 exercises together. And if you're watching this video, some questions will pop up for you to complete them. So best of luck with the questions, and I will see you on Monday. Have a great day.